All right, here, these are some problems that students in class asked about. So they're on 5.2 and 5.3, so I thought I'd go through some of them. We'll start with number 20. Number 20 is a factor problem. So it's 4 tangent squared beta plus tangent beta minus 3. Now the first, if it'll make this a little simpler, you can think about it like you would in algebra. If I replace the tangent beta with x, this would be 4x squared plus x minus 3. Now if you use the grouping method of factoring, first you take 4 times negative 3, so 4 times negative 3 is a negative 12. Now we want to look for two factors of a negative 12 that if we added them together, we'd get this middle coefficient 1. So what two factors of a negative 12, if you added them together, would equal 1? Well, that would be 4 and negative 3. So we're going to split this up. We're going to leave the 4x squared. Now this positive x, we're going to split it up as a positive 4x and a negative 3x. So that x has now become 4x minus 3x, and then we still have the minus 3. We did that so when we group them, like if we group these first two together, we look for some factor that's common to both of these. Well, you can take a 4x out of both. If we divide by 4x, 4x squared divided by 4x is x. 4x divided by 4x is 1. Now we look for a factor that's common to the other two. Well, that would be a negative 3. If we factor out a negative 3, so here if we divide by negative 3, we get x. Here we get plus 1. Now we notice this is the same 1 on both of them. That's what we want to have happen. That's one of our factors. So x plus 1 is one of our factors. The other factor is the combination of the two things we took out, 4x minus 3. So there's the factored form. Well, now we started off with tangents and we replaced tangent beta with x. Now let's put it back in. Where there's an x, we're going to put a tangent beta. So this would be 4 tangent beta minus 3, and that would be tangent beta plus 1. So that's number 20. Okay. 24, this is a verified problem. So we have 1 minus sine squared over cosine equals cosine theta. Now when I look at that, what I see is that here I have a cosine and a cosine and a sine squared. So to me, the oddball is the sine squared. I would like to change that if I could. I'd like to change it to cosine. Well, one of our identities, that very first one we had, says sine squared plus cosine squared equals 1. Well, if I took that, if I moved the sine squared to the other side, on this side I'd have 1 minus sine squared equals cosine squared. Well, if we look at that here, that means on this top, 1 minus sine squared, we can replace that with cosine squared. So now we have that. Well, now we can divide top and bottom by cosine. If we divide the top by cosine, we just get cosine. To get the bottom, we just have 1. So now we're right here and we're finished. Okay. 26 is another verified problem. So it has 1 minus cosine squared x times 1 plus cosine squared x equals 2 sine squared x minus sine to the fourth x. Now when I look at this, I see on the left side I have cosines, on the right side I have sines. Now keep in mind, our goal is to get the two sides to match. Well, if they're going to match, shouldn't we have the same trig function on both sides? So that's the first thing I would look for. We either need to change these cosines into sines or change these sines into cosines if we want them to match. Well, I chose to do the left side because I saw some stuff I could do, and also I saw a sine to the fourth. Well, we don't have an identity anything with sine to the fourth in it, so I would stay away from that. But we could have done either side. So on the left side, here I see that 1 minus cosine squared. Well, again, with our identities, if we take this first one here, if I move the cosine squared to the other side, this says 1 minus cosine squared equals sine squared. So here, this 1 minus cosine squared here, I can substitute sine squared in its place. So that gets me part way there. I got rid of the one of the cosines and turned it into a sine. Now this one here is not quite as good because of the 1 plus cosine squared, but if we go to that same identity, if I wanted to get cosine squared by itself, if I moved the sine squared to the other side, this would say cosine squared equals 1 minus sine squared. So in place of that cosine squared, I'm going to put 1 minus sine squared. Now we still have this 1 out here. So now that left side looks like that. Well, let's see, if I add here, that's 2 sine squared x. Sorry, I forgot my plus sign. That's 2 plus sine squared x. And out in front I have sine squared x. Well, if you saw something like this in algebra, you'd say, oh, it's time to distribute. Let's do that. If we take sine squared times 2, we just get 2 sine squared. Then if we take sine squared times sine squared times sine squared is sine to the fourth. Well, now if you compare the two sides, oops, I forgot that was a minus in there. Doggone it. Sorry, that's a minus in there. That was a minus here. Well, now the two sides match and we're done. All right. Let's go to 5.3 now. Students asked about 34. Now 34, two things. So we have the sine of theta equals cosine of 2 theta minus 10 degrees. Well, whenever you see sine equals cosine, that goes back to the cofunction identities, right? One of the pairs of cofunctions is sine and cosine. So we have that. Sine and cosine are cofunctions. Now, if two cofunctions are equal to one another, their angles have to add up to be 90. So let's just say that. This angle plus this angle over here has to equal 90. So we know those two angles have to add up to be 90, so we just did that. Let's see now, if I combine like terms, 3 theta, if I move the 10 to the other side, that's 100. Now I divide by 3, and I get 100 thirds. You could change that to 33 1/3, it's fine. But it's important, one, recognizing that these are cofunctions, and when cofunctions are equal, their angles add up to be 90, so we just added them up to be 90. All right, now let's look at 36. 36 is the one I mentioned in the notes. You will see problems doing the same type of thing over and over for the rest of this chapter. They tell us like 3 things. Cosine theta equals -1/5. I'm sorry, cosine s equals -1/5. Sine of t equals 3/5. And s and t are both in quadrant 2. They asked us to find the cosine of s plus t. Now, the first thing I would do is look up. If you're asked you to find something, you have a formula for it, look up that formula. Well, if we look at our sheet in the sum and difference identities, here, that's the sine of s plus t. I'm sorry, the cosine of s plus t. Well, right here we have the cosine of a plus b. So we're going to make that the cosine of s plus t. So wherever there's an a, we're putting s. Wherever there's a b, we're putting t. So here, if we just copy down that identity, so you just want to look right at your sheet and copy it down. That's the cosine of s times the cosine of t minus the sine of s times the sine of t. So just copy that identity right down, only with s's and t's instead of a's and b's. Now, once you have that down, in your given, they will have given you two numbers to plug in here. Where it says the cosine of s is a negative 1/5. Well, right here is the cosine of s. Let's replace that with negative 1/5. It says the sine of t equals 3/5. So wherever there's a sine t, like right here is the sine of t, we're going to replace that. We're going to substitute in 3/5. So we had four numbers we needed. We have two of them. Now the last two, you're going to come from drawing a picture. It says s in quadrant 2. Well, let's draw that. So let's go here in quadrant 2. Let's draw an angle s and a triangle to the x-axis. Now we know the cosine of s is a negative 1/5. Since cosine is adjacent over hypotenuse, the adjacent's negative 1, the hypotenuse is 5. The other leg will be 25 minus 1 is the square root of 24, or since 4 goes into that, we could call it 2 radical 6. So that's our opposite side. Well, now that we know the opposite side, we need the sine of s. Well, sine is opposite over hypotenuse, so that's 2 radical 6 over 5. I just left the negative in from up above. So that's how you find the missing parts. We're going to do the same thing to find the cosine of t. Let's draw it. We know t is also in quadrant 2, so let's draw t over there. Now we know the sine of t is 3/5. Well, sine is opposite over hypotenuse, so the opposite is 3. Hypotenuse is 5. Missing side, 25 minus 9 is 16. Square root of 16 is 4. Since it's left, it's a negative 4. Well, now using that triangle, we need the cosine of t. Cosine is adjacent over hypotenuse, so negative 4 over 5. So now that we plugged in our numbers, it looks like that. Now we just have to multiply and combine. So here, negative 1 times negative 4 is 4. 5 times 5 is 25. Let's see, then minus, here 2 radical 6 times 3 is 6 radical 6. 5 times 5, 25. We have a common denominator, so we can combine those. You can't do much except put 4 plus 6 radical 6 all over 25. You can't combine those otherwise and simplify. So that's the cosine of s plus t. Now if I want the cosine of s minus t, well, the only difference in those two identities, if you look at those sum and difference identities, the only difference is when it's a cosine of a minus b, it's a plus in the middle. When it's a plus b, it's a minus in the middle. So the only thing that changes is the sign. So since this is s minus t, we need a plus in the middle. So if we take those same two fractions, only now we're going to add them, then it's 4 plus 6 radical 6 over 25. All right, so hopefully that helps you to understand some of those on 5.2 and 5.3.